In this video, we want to look at the concept of position and displacement and all of the various ideas that go along with understanding how we find position and what the difference is between distance and displacement. Position is defined as the location of an object. In physics, we'll typically specify this with graphical coordinates. So if we're dealing with the x-axis, for example, we set the origin as our 0 point, and then we tell how far away from the 0 point the position of an object is located. The variable that we use for position, which you learned in your units and variables video, is x, and we're generally going to use a position with meters as the units. We will generally set the origin as 0. That's not required, but that's generally what we're going to do to make things as easy as possible. One of the things that you're going to see in physics that's a little different from math classes and a little different from things you may have seen before is that we have to specify direction. Anytime we're solving a problem that's in one dimension, we are generally going to specify direction as positive and negative. So if we have things moving left and right, we'll make one direction positive, the opposite direction negative. Or if we have things moving up and down, we'll make one direction positive, one direction negative. It does not matter which way you choose to make positive and which way you choose to make negative. It makes absolutely no difference as long as you are consistent within a given problem. You can change it the next time you do a problem to do something that makes more sense to you in the next problem. But each time you must specify which way is positive and which way is negative. And you must understand in physics that when you have a positive or negative value, it doesn't mean greater than 0 or less than 0. It just means opposite directions. So if you see positive 5 as one position and negative 5 as the other position, it just means they're in opposite directions. So for example, if I were to draw an axis here and I said this is my 0, and I have a scale 1, 2, 3, 4, 5. I have a scale 1, 2, 3, 4, 5. I've got one object at this point and one object at this point. I would say that the square has a position I'm going to make to the right positive. It does not matter. You could make to the right positive or negative. If I make it positive, I'm going to say that the square has a position of positive 4 meters. And I'm going to say the triangle has a position of negative 3 meters. So to the right is positive in this case, and to the left is negative. Someone else could make to the left positive and to the right negative. So they would get negative 4 for the square and positive 3 for the triangle. It doesn't matter which one you choose to do as long as you're consistent throughout the problem. And understand that positives and negatives mean opposite directions in this course. Now, when we talk about position, we generally are more interested in talking about the distance or displacement that something travels, the actual movement of an object. Just an object sitting still in place isn't very interesting to study, but an object that's moving has a lot more interest to us and is a lot more applicable to real-world cases. There's a big difference between distance and displacement. Distance was our variable d that we talked about the other day. It's going to be in meters. Distance is the interval between two locations is one simple definition. A very precise definition would be the scalar measure of the interval between two locations measured along the actual path connecting them. So if you were to walk, say we had a person, and they walk 5 meters to the right, and then they turn around and walk 4 meters to the left, they would travel a total distance of 9 meters. So they walked 5 meters, then they walked a distance of 4 meters for a total of 9 meters traveled. The difference becomes when we start talking about displacement. Displacement, if you'll remember, is our variable delta x. It's also going to be in the unit of meters. But this is what we refer to as a vector. A vector is something that includes direction. So this is the distance and direction of the shortest path between the initial and final position. So we go back to that same example we had before. Someone walks 5 meters to the right and then 4 meters to the left. Their original position was 0. Their final position is +1 if I'm making to the right positive. So the displacement here would be 1 meter positive or to the right. So it's just the distance and direction from the initial position to the final position, irregardless of the path that they traveled. So they walked a distance of 9 meters, but their displacement is only 1 meter. This is the example that we were just been looking at in the two cases. 5 steps to the right, 4 steps to the left. The distance, so once again draw this out. The distance would be 9 meters. Doesn't care about direction. The displacement would be 1 meter to the right, or 1 step in this case, I guess. Big difference you see there between distance and displacement. Okay, let's look at another example here. Amy runs 2 blocks south, then turns around and runs 3. Let's do these both as blocks. Didn't mean to do miles and blocks. So we go 2 blocks south, then turn around and go 3 north. I'm going to set this as my 0 point. I'm going to make up positive this time. So she starts going -2 blocks and then goes +3 blocks. Her final position will be here, which is her final position will be 1 block north, or positive. The distance she traveled would be 5 blocks, and the displacement would be 1 block north. The final position and the displacement are the same here because we set the initial position as 0. Okay, the last one. Neva swam 3 complete laps in a 50-meter pool. 1 lap is to the other side and back. So she went in a 50-meter pool, down, back, down, back, down, back, and ended up right back at this original starting point. Her final position, if we set her starting point as 0, would be 0 meters. Her distance traveled would be 150 meters. Her displacement would be 0 meters. Now, one final case. Now we're going to take in some different directions. Calculate the position, distance, and displacement of the following situation. Ryan runs 50 meters north, 30 feet west, and then 30 feet south. Started here. In the end, traveled this basic displacement. If we think about his final position would be 20 feet north and 30 feet west of where he started. The distance he traveled would be 50 plus 30 plus 30, or 110 feet. His displacement would be the 20 feet north, 30 feet west. If we wanted to figure out the total of that, think of this drawing of what it would actually look like now. 20 north, 30 west. We could use our triangle math and figure out the length of the hypotenuse to figure out the length of his final displacement, which in this case would be 20 squared plus 30 squared equals c squared. So the square root 1300 should be 36 meters, and it would be 36 meters northwest. So you must include both 36 feet northwest, distance and direction. Distance and displacement are very different things. Distance is the total distance traveled. Displacement is the difference from the starting position to the final position. We'll generally set our origin position as 0, our original starting point is 0. That's not required. And we do need to make different directions, positive, one direction negative. We couldn't do it in this last case because we had both up and down and left and right, so we made northwest, southeast as our various directions.